Hello guys, I will be doing the physics quiz 3.22 and 3.23. The rest will be done by someone else. I will be doing this one for the periodic. Let's start with this question. We can obviously utilize the rule m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. This is the rule we can be using. Let's interpret the question. We have two particles A and B. They have masses 60 and 40. They're moving towards each other. Okay, so we can draw these arrows of motion. They're moving towards each other. Both of them have a speed of 5 meters per second. The thing is, one of them is moving in the positive direction, one of them is moving in the negative direction. Just as an exercise, let's just say that A is positive and B is negative. So the right is the positive. So the right is the positive way. We specified this. Now, after collision, they stick together. We have to find their speed. We have to convert these masses into kilograms. So it becomes 0.06 kilograms and 0.04 kilograms. So basically, 0.06 times u1, which is 5, plus 0.04 times negative 5 is equal to mv. We have to combine both masses. 0.06 plus 0.04 is gonna be 0.1, and then v, velocity. Let's multiply these numbers. 0.3 minus 0.2 is equal to 0.1 v. 0.1 is equal to 0.1 v, and then v is equal to 1. Okay, and since the answer is positive and we chose A to be positive, it will be moving in the direction of A. Now what if we chose A to be negative and B to be positive, يعني the opposite way? We will get velocity is equal to a negative number, but either way we will still submit a positive number because they asked for speed, not velocity but speed. And the answer will also be A because technically it's moving in the opposite of the negative direction. And in math we learned that negative is same as positive, so you can interpret it as in this way, if that makes it easier for you to understand. Okay, now for this question, we can also use m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Okay, we have masses. We have a cart that has a mass and it's moving at a specific direction, and it's moving towards another cart named B, and this cart B has an unspecified mass and it's stationary, so the velocity is 0. After collision, the carts start moving in opposite direction, and both of them have a speed of 1. They said that take A as positive, the initial direction of A. Now they ask for the momentum of cart A in the initial momentum and the mass of cart B. Let's visualize this by drawing. We have cart A here and we have cart B here. Cart A is moving to cart B. Cart B is not moving. This is cart A. It's moving at 3 meters per second and they told us to take it positive. Okay, this is before collision. Now after collision, when both of these carts are together, they both collide with each other with a specific force. Like they collide each other, and this is momentum. So then what will happen? They said that after collision, they will start moving in opposite directions. So now A starts to move here and B starts to move here. So A is contradicting its original direction of motion. So if the right was positive, A is now moving to the left, so it's negative, and B is moving to the right, so it's positive. So using the information that we inferred, 4, just substitute, times 3 plus m times 0, right? Because it's stationary, which is 0, is equal to 4 times negative 1, because now A is moving in the negative direction, plus the mass of B is unknown, times 1. It's positive because it's moving to the right, and we chose that A moving to the right is the initial. You can even choose A moving to the left. At the end, you will still get the same answer. So now we can get that this is equal to 12, and this is negative 4 plus m. And then if we take it to the other side, we get m is equal to 16 kilograms, and this is what we get. And they want the momentum of cart A before collision, which we got it was 12. It was 12, and we can do even P is equal to m delta V. M is 4 and delta V is 3. So 4 times 3 is equal to 12. Next question. Okay. We have a firework. It's moving 2 meters per second to the right. Let's take it to be the initial direction of motion, the positive, okay? It explodes and it breaks into two equal fragments. One of the fragments now starts moving to the left, okay? And one of them is moving in an unspecified direction, okay? So we have a firework. We can use the rule m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Okay, let's substitute the masses. That they didn't give any mass. So usually if we have a firework, this would mean that these two particles are stuck together, okay? But since everything is conserved and we want to keep mass equal on all sides, we can just consider that it's 2m plus 2m. Okay, you can take it as 2m. Okay, it's gonna be the same thing, it's gonna be 4m. That's the original way the question was taking it, but if we do it this way, it's gonna be more simplified for you. It's gonna be easier for you to understand. 2m plus 2m, because the two fragments were one fragment at the beginning, but since we want to keep mass constant on all sides so we can simplify it, it's easier to do it like this, separate fragments. So 2m plus 2m is equal to m times negative 10. The reason I put negative is because at the beginning we chose the right to be positive, right? It's positive, we chose it, okay? So if it's moving to the left, left is now the negative, so it's negative 10 plus m times v is unknown. Now since we kept these two separate and we did not add them together, we can divide by m, divide by m, divide by m, divide by m on all sides. They will or there's no need to divide by m, it will just instantly all cancel out. So now we're left with numbers. 2 plus 2 is 4. So then we're left with negative 10 plus v. And then v is equal to 14. So we have 14, and since it's positive and we chose the right to be positive, we will get right. You can even choose left to be positive, but again, as question number 1, you will still always get the same answer. Okay. The magnitude of trolley A's momentum before the collision. We have a system of two trolleys, 15 and 0. Okay. Momentum is equal to the mass times the velocity. What's the mass of trolley A? 3 times the velocity of trolley A is 5. 3 times 5 is going to be equal to 15. Now the momentum of trolley B. We have momentum is equal to the mass of trolley B, which is 2 times 0. Why 0? Because it's stationary. So it's 0. So now we have the initial momentum. Okay? Which is 15, because 15 plus 0 is 15. They ask for the magnitude of momentum of the combined trolleys just after the collision, and they want the speed of the combined trolleys. Okay, they want speed and momentum. Using the rule m1u1 plus m2u2 is equal to m1v1 plus m2v2, we can just substitute all the values. So basically 3 times 5 plus 2 times 0 is equal to mv, because they said it's combined. So basically combined means that they stick together. Okay, they stuck together. So you add 3 plus 2, 3 plus 2, and you get 5. 5v. Because velocity is what you're trying to find. And we learned a rule, sorry for this window. We learned a rule that momentum of the system before the collision and after the collision is always equal if there is no external unbalanced force applied. So the momentum is always conserved. So if the momentum before was 15, so 15 plus 0, which is 15, if that is before, it will also be the same after. So momentum will always be the same before and after. And then after, they were asking for the velocity. So if we add this together, we get 15, of course, and then is equal to 5v. V is equal to 3. So the velocity of the combined trolleys is going to be equal to 3, and we have 15 here. Now they said, instead of sticking to trolley B, trolley A now moves with a velocity of 2 meters per second in the same direction as before collision, which means it's still positive. So in here they give us a scenario where the trolleys did not stick together. So we use m1u1 plus m2u2 is equal to m1v1 plus m2v2. 3 times 5 plus 2 times 0 is equal to 3 times 2 plus 2 times v. You add these together, you get 15 is equal to 6 plus 2v. Move this to the other side, you get 9 is equal to 2v, and v is equal to 4.5 meters per second. Okay, here we have a system of a gun and a bullet. We have two scenarios in the system. Scenario 1 is when the bullet is still not fired, and when the bullet is not fired, that means that the bullet is stationary, which also means that the gun is stationary. In scenario 2, the bullet will be fired, and if the bullet will be fired, thus that means that the gun will also move a bit. So we have m1u1 plus m2u2 is equal to m1v1 plus m2v2. What's m1? We have to convert it to kilograms, so 0.015. Okay, divide by 1,000 or multiply by 10 to the power of negative 3. This is already in kilograms, okay? So 0.015 times what's the initial velocity of the bullet? It's 0, okay? It's initial because it's stationary. Plus the second object, which is the rifle, which is 5 times, also 0, it's stationary. Then we have the mass of the bullet, 0.015, plus the bullet. Then we said that it's fired at a speed of 500 meters per second. So times 500 plus 5 times v. We add these together, we get 0 is equal to 0.015 times 500. Put it in your calculator and you will get 7.5. So 7.5 plus 5v. Move 7.5 to the other side, you will get negative 7.5 is equal to 5v, and v is equal to negative 1.5 meters per second. Let's answer the questions. They said the magnitude of the initial momentum. Initial momentum, we calculated it to be 0. Okay? Now they said the recoil speed of the rifle. So the speed of the rifle, we calculated it to be, here we got the velocity of the rifle, which is negative 1.5, but they asked for the speed. So it's not gonna be negative, it's gonna be positive. So positive 1.5 meters per second. Okay. Now, for this question, usually if you're unsure of everything, just write the givens for everything. So mass is equal to 2 kilograms. Force is equal to 10 newtons. Time is equal to 3 seconds. They want velocity. Is m1u1 plus m2u2 is equal to m1v1 plus m2v2? Is it suitable for this rule? No. But we did learn another rule, which states that what is impulse? What is the meaning of impulse? Impulse, it means the change in momentum. Okay. what is the sign يعني what is the unit for impulse? It's newtons times second, and the unit of momentum, it's kilograms times meters per second. Now these are the words. Don't get confused between words, units, and symbol. What are the symbols? It's J is equal to the change del it's equal J is equal to delta P. So basically the rule we learned is J is equal to delta P. What is J? The impulse is force times the time, and the momentum is equal to the mass times the change in velocity. Now we can substitute all values. The force is equal to 10 times 3, and then the mass is 2 times delta V. What's delta V? It's V final minus V initial. V initial, it's at rest, so V initial is 0. So anything minus 0 is that number. So now we're left with 2 times V final. So 30 is equal to 2 VF, okay? And then we can find that VF is equal to 15, because 30 divided by 2. Okay. This one looks like we also have to use the rule F times T is equal to M delta V. What is the force? The force is what we need to find. The time is 250 millisecond. How to convert from millisecond to second? You divide by 1,000, or you multiply by 10 to the power of negative 3, so it becomes 0.25. Okay, 1, 2, 3. So so F times 0.25, okay, is equal to the mass, which is 1,500, times times delta V, which is V final minus V initial. What is V final? V final is 5. V initial is 20. Let's imagine it. Let's imagine something is moving to the right. Let's see that the right is positive, and then it rebounds at a speed of 5 meters per second. Let's choose 5 to be negative and 20 to be positive. So it becomes V final, which is 20 minus V initial, which is negative 5. So 20 minus negative 5 is the same. So negative becomes positive. So 20 plus 5 is 25. Now we can just multiply these two numbers. We divide by 0.25 and divide by 0.25. Put this on the calculator. You will get F is equal to 150,000 newtons, and they asked for kilonewtons, so basically it's 1,000 newtons. So 1, 2, 3, so basically 150 kilonewtons. Now for the next one. Okay, this is easy. If the wheel pushes the earth backward, that means that, let's do it together. Wheel earth backward, it will be earth wheel forward, the same thing. Human ground backward, ground human forward. Propeller water backward, water propeller forward. Okay, the same thing here. Engine gases downward, gases to engine upward. Just inverse the words and the opposite of forward slash backward. Now they asked for momentum. What is the rule for momentum? It's M delta V. What's the mass? The mass is 0.009 times 380. This will get you 3.42 meters per second. I prefer to put 3.42, but both answers are accepted, either 3.4 or 3.42. Okay, now we have another system. M1U1 plus M2U2 is equal to M1B1 plus M2V2. If you're ever lost on which rule to use, always write the givens first, then write the rule. So now we have the mass of a gun. Let's just substitute all values. 0.5 times Okay, fine. It's always better to interpret everything. We have the mass of a gun and the mass of a bullet, and we said that the bullet is fired, and when the bullet is fired, it has a speed. It has a speed, and then after, if it has a speed, that means that the gun will also move. Always, we have two scenarios: the scenario where nothing is moving yet, and the scenario where stuff are moving. In the scenario where nothing is moving, everything is stationary, so velocity is zero. So the gun will have a velocity of 0, so 0.5 times 0 plus 0.009 times 0 will be equal to mass 1, which is 0.5, and the mass of the gun is the velocity of the gun is unknown, plus 0.009 times 300. Okay, now we can add these both. We get 0 is equal to 0.5 v plus 0.009 times 300. Put it on the calculator and you will get 2.7. Okay, so this is basically just recognizing that in a system there are two scenarios: scenario 1 where nothing is moving, everything is stationary in the beginning, and scenario 2 where things starts moving. So now you can move 2.7 to the other side, so negative 2.7 is equal to 0.5 v. Negative 2.7 divided by 0.5, and you will get negative 5.4. They asked for the speed and not the velocity, so the answer will be positive. And this is just definition. The total momentum of the object is always equal to the total momentum of the object before and after collision. It's always the same. Okay, we have mass, we have velocity. No, they want velocity. Okay, they want it before and after. Before and after, we use the rule m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So 0.2, actually let's imagine it. We have a ball of mass 0.2 kilograms. It's moving leftward at 5 meters per second. Leftward like this. So 0.2 kilograms, 5 meters per second leftward. And it collides with the stationary ball that has a mass 0.3 kilograms. Velocity is equal to 0. Now when this collides with this, they will stick together. Okay, they will stick together. So we use basically m1 u1 plus m blah blah blah. So what is let's say that leftward is positive. Okay, let's just say that it's positive. Okay, so 0.2 times 5, okay, plus 0.3 times 0 is equal to mv, because they stuck together. Now add both of their masses, you will get 0.5 v. Now 0.2 times 5 is 1 actually, plus 0, so 1 is equal to 0.5 v. Divide by 0.5, so 1 divided by 0.5 is equal to 2. What is impulse? Impulse is equal to the force. J is equal to force times time, so the force is 500 times 0.16. 500 times 0.16, you will get 80. Okay, let's imagine this. We have a ball. It collides with the ground at a speed of 3 meters per second, and then it bounces back up at 2.5 meters per second. Let's see that when it goes to the ground, it's negative 3, and this is positive 2.5. So we have the force. They want the impulse. Impulse is equal to force times time. But here we only have givens of mass and velocity. And since we learned that the impulse is equal to the change in momentum, basically impulse, and since force times time is equal to mass times velocity, basically we can derive that the impulse is equal to the mass times the velocity. Since impulse and momentum are equal to each other, we can deduce this rule. So basically the mass, we can convert it to kilogram, 0.2, so 0.2 times delta V. V final minus V initial. V final is negative 2 point, actually we chose it to be positive 2.5, right? Because when we did it like this, we got negative 3 and then 2.5. We chose it to be positive, so 2.5 minus negative 3 minus minus is positive, so 2.5 plus 3 is equal to 5.5. So 0.2 times 5.5 and you will get 1.1. Thank you for watching the video. If you have any questions, please don't be shy to ask me privately or ask anyone. Thank you and good luck.